Right, we're going to carry on the last section of chapter 11 on thyristors. We are discussing the programmable unijunction transistor, or the PUT. You can mark the introductory paragraph there again. It refers to the UJT, which we didn't discuss, but we will see later on that the PUT actually replaced the UJT. And the UJT is not actually a thyristor. But anyway, the programmable unijunction transistor, or the PUT, is actually a type of thyristor and not like the UJT in all terms of structure, but we haven't discussed the UJT, so don't worry about that. The only similarity to UJT is that the PUT can be used in some oscillator applications to replace the UJT. The PUT is similar to an SCR, except that its anode to gate voltage can be used to both turn on and turn off the device. Right. Of course, again, I have to know the symbol. PUT is a type of three-terminal thyristor that is triggered into conduction when the voltage of the anode exceeds the voltage at the gate. Notice that the gate is connected to the N region adjacent to the anode. This PN junction controls the on-off states of the device. All right. But I've marked here in the book as well. The gate is always biased positive with respect to the cathode. Take note. When the anode voltage exceeds the gate voltage by approximately 0.7 volt, the PN junction is forward biased and the PUT turns on. The PUT stays on until the anode current falls below this level, and then the PUT turns off. All right, now setting the trigger value, and this is where they talk about programmed. Setting the trigger voltage, the gate can be biased to a desired voltage with an external voltage divider as shown in figure 1143. Look there in 1143, external voltage divider. You're familiar with that? So that voltage determines where the PUT will switch on, so that is where the programmable term comes in. So that when the anode voltage exceeds this programmed level, the PUT turns on. Alright, and there's the characteristic curve of this device. So you have to be familiar with the characteristic curve of this device as well. So the device turns on, and it remains on as long as the voltage remains higher than this voltage of VG and the voltage of my the voltage divider. Anyway, let's have a look at an application on page 578. A plot of the anode to cathode voltage VAK versus anode current IA in figure 1143B reveals a characteristic curve similar to that of the UJT. But don't worry about that, we didn't discuss it. But as they say here, therefore the PUT replaces the UJT in many applications. Anyway, the basic operation of the PUT is as follows. The gate is biased at plus 9 volts by the voltage divider consisting of resistors R2 and R3. As I can see here, the voltage divider that we've discussed earlier, R2 and R3, supply voltage of 18 volts. But with my voltage divider here, I can see that the two resistors are of the same value, so it will halve the voltage. So that I have a VG of 9 volts. Alright, so when the DC power is applied, the PUT is off and the capacitor charges towards 18 volts through R1. Here you can see is my capacitor, and it charges through R1 up to a value of 18 volts of the supply. But when the capacitor reaches VG plus 0.7, VG in this case, as we've seen, we've set it at 9 volts. That was the programmable part, the programmed part. I can change that voltage with changing the values of my voltage divider, of course. Plus the 0.7 volts. Then the PUT turns on and the capacitor rapidly discharges through the low on resistance of the PUT and R4. So I can see it will discharge through there. Okay, so there I can see my relaxation oscillator, as we've seen with previous devices as well. All right, but a voltage spike is developed across R4 during the discharge. As soon as the capacitor discharges, the PUT turns off and the charging cycle starts over, as shown by the waveform in the figure 1144. So there, when it discharges, we can see here, I get that spike, discharge, and the whole process repeats itself. Right, so that's an application, the PUT relaxation oscillator. And that concludes chapter 11. This last section, the programmable unijunction transistor, and the same applies as for all the other sections that we've discussed in this chapter. And this concludes also the syllabus for this semester.